Hello everyone, I am Asha Garg and today I am going to explain you the routing protocols of ad-hoc network. So firstly, what is routing? Routing means we have to send a packet from one source to another destination in a network. And this routing protocols helps us to find out the best route to deliver a packet from source to destination in an ad hoc network. Host routing protocol is flat ad hoc routing. In this routing, all nodes play an equal role in routing. Here, node means all the system that consists routers, source and destination and all the intermediate devices in a network. No effort is made to organize the network, only to discover the best route hop by hop to a destination by any path. From this, we mean that there is no need to organize the network. We only want to discover the best route by which we can transfer the packet from source to destination hop by hop. In flat ad hoc routing, we assume that all the routers or the devices sitting on a flat geometric plane. Flat ad hoc routing does not comprises set of hierarchies with cluster of nodes, special nodes acting as a head of a cluster, different routing algorithms inside or outside certain region. From this, we mean that V does not contain those nodes which form a cluster or acting as a head of a cluster, or the routings that are performed inside or outside the certain region. We only comprises those nodes which are having equality. As I explained earlier, all the nodes play an equal role in routing. This flat ad-hoc routing again falls into two subcategories. First is proactive protocols, second is reactive protocols. This reactive protocols is also known as on-demand protocols. This protocol discover routes when needed. Source-initiated route discovery. And the second one is proactive protocols. Traditional distributed shortest path protocols, which is based on periodic updates. Proactive protocols. These proactive protocols are also known as table-driven routing protocols. In this protocol, each node continuously maintains up-to-date routes to every other node in the network. By this, we mean that every node continuously or regularly maintaining its information that how to reach another node in the network. This routing information is periodically transmitted throughout the network in order to maintain routing table consistency. This routing table is maintained by all the nodes in the network in which they contain the routing information that how they can communicate with the other node in the network. If a route has already existed before traffic arrives, transmission occurs without delay. That means that if we already found the path from source to destination, then if there is source wants to send data to destination, then it will be transmitted without any delay. Otherwise, this traffic packets should wait in queue until the node receives routing information corresponding to its destination. DSDV or Destination Sequence Distance Vector is a classic example of this proactive protocol. Now we see some advantages of proactive protocol. The first is it can give QoS guarantees related to connection setup, latency, or other real-time requirements. As we know that in proactive protocols, we already know the path from source to destination. That's why it will give us quality of service. in terms of connection setup, latency, or any other real-time requirements that need it dynamically. The second one is, as long as the topology does not change too fast, the routing tables reflect the current topology with a certain precision. This means that if the topology of the network does not change, it will reflect the current topology very correctly. Disadvantage of this proactive protocol are overheads in lightly loaded networks. This means that if the network is having very low traffic, then it will be act as an overhead. Independent of any real communication, the algorithm continuously updates the routing table. These proactive protocols needs regular updates for routing independent of the real combination going on the network. Third is a lot of unnecessary traffic and drains the batteries of mobile devices. As we know that in proactive protocols, the routers needs up to date routing table. That's why it becomes a traffic on the network, which is act as a very big disadvantage of proactive protocol.
Now, the next protocol is reactive protocol. It is also known as on-demand protocols. A node initiates a route discovery throughout the network only when it wants to send packets to its destination. As the name suggests, on demand, which means when demand comes, then it starts initiates a route discovery, which is initiated by the source node. Once a route has been established, nodes maintain the routes to active destinations. That means when the route is discovered, the nodes have to maintain that routes to the active destinations which are currently needed packets to receive. Communication overhead is reduced. Of course, it is reduced as we see earlier in proactive protocol. We have to send the routing information up to date. But in this, we does not need that. When we want to send packets to destination, then we start initiates a route discovery. But this communication overhead is reduced at the expense of delay because now when the demand comes, then it initiates a route discovery. That's why it consumes time to route search. The key goal of this reactive routing is reduction in routing overhead, and it is very useful when number of traffic sections is much lower than the number of nodes. The two key methods from which the source router initiates route discovery are source routing and backward learning. As we know, this reactive routing protocol introduces delay because it initiates route discovery when demand will come. Here are some advantages of reactive on-demand routing. Routing only when needed. First of them is eliminate periodic updates. As in proactive protocol, here we did not have to update our routing table periodically. Second one is adaptive to network dynamics. This reactive routing is very much suitable where the network topology is changed frequently. Third one is scalability as long as there is only light traffic and low mobility. If our network will expand in future, then it is no issue in reactive routing. There are some disadvantages also in reactive routing. First is high flood search overhead with mobility distributed traffic. In the case of mobility or distributed traffic, there is a overhead of searching the path causing high flooding. The second of the disadvantage of this is high root acquisition latency. Now I will explain you shortly that how this source node initiates root discovery. This source floods the network with a root request packet when a route is required to a destination. Flood is propagated outwards from the source. That is, from the source node, it starts sending packets to the neighboring nodes. Peer flooding means every node transmits the request only once. Then the destination node replies to that request, which was sent by the source node. Reply uses reversed path of root request. That means it follows the same path from where the root request has come. It sets up the forward path. The two key protocols of this protocol is DSR and AODV. DSR means dynamic source routing and AODV means ad hoc on demand distance vector. Now, the second type of ad hoc routing protocol is hierarchical ad hoc routing. In this routing, mobile nodes are organized in clusters. That means all the mobile nodes are grouped in clusters. This grouping may be based on a number of criteria, but most commonly they are based on either location or functionality. Location or the geographical area where these mobile nodes exist, or functionality. The nodes perform same types of functions. The cluster boundaries are based on transmission range of the cluster leaders known as cluster head. This cluster head controls the cluster containing all the mobile devices. All nodes within the cluster and other cluster heads use this as gateway for the cluster. So in this hierarchical ad hoc routing, we learn three things. First is we met cluster, which are the group of mobile nodes. Second one is cluster head, which controls these clusters. And third one is gateway, which is used by the nodes within the cluster and all the other cluster heads. One or multiple levels of hierarchy. In this hierarchy ad hoc routing, we have multiple levels. Clusters can be combined to form superclusters, building up a larger hierarchy. One cluster head also acts as a head of a supercluster, routing traffic to and from the supercluster. Different routing protocols may be used inside and outside the cluster. From this, we got to know that we have multiple clusters in our network. If we want to send a packet in the same cluster, we have different routing protocols. And if we want to send in interclusters, then we have different routing protocol. One of them is cluster head gateway switching routing, which is a typical representative of hierarchical ad hoc routing algorithm. In this diagram of hierarchical ad hoc routing, we have four clusters 1, 2, 3, and 4. This second, fifth, eighth, and 11th node are the cluster head of the respective circles, and other one is internal nodes. And in the black shade are 4, 7, and 10 are the gateway nodes which communicate between the two clusters. I hope you understand this well. Some of the advantages of hierarchical routing are for larger networks, clustering of nodes can be scalable and effective solution. As we know, we have many clusters in our network, so for large networks, it is a very efficient solution. If a cluster can be established, nodes typically remain within a cluster, only some change clusters. If the topology within a cluster changes, only nodes of that cluster have to be informed. That means that any changes to any cluster remained in that cluster only. Any other cluster does not affect with that. Nodes of other clusters only need to know how to reach the cluster. There is no need to inform the topology changes of that cluster. It hides all the small details in clusters which are farther away from that cluster. Of course, if there is some advantage, there is some trade-off also. First is overhead and confusion for leader selection. How we achieve the cluster head of any cluster. Second one is scalability, intercluster or intercluster. The third routing protocol in an ad hoc network is geographical routing. It makes use of location information in routing. The location of both the sender and the destination is known, which is an act as an assumption in geographical routing. One way to acquire position information is via the GPS, Global Positioning System. This geographical routing can be explained better through the diagram. Here we can see this is the source which is further away from the destination node. Contains several nodes and obstacles to send packets from source to destination. Here, a node requires knowing only the location information of its direct neighbor. The mechanism used is greedy mechanism, where each node forwards a packet to the neighboring nodes only, which is closest to the destination node. Here are some advantages of geographical routing. First is it is position based routing protocol have the potential to reduce or control overhead and reduce energy. As flooding for node discovery and state propagation are localized to within a single hop because we need to send the packets only to the neighboring nodes. Second one is the mobility support can be facilitated. Since each node sends its coordinates periodically, all its neighbors update their routing tables accordingly. It is also scalable. That is, we can expand the size of the network. The size of routing table depends on network density, not on network population. Thank you guys. I hope you will enjoy this video well. I hope you understand the routing protocols of ad hoc network. Thank you. Bye bye.